Hello, all. AI is the word that is ruling the world right now. A lot of companies have been starting to use AI in their products and in their algorithms and in their applications to enhance or uplift themselves. And a lot of students are started to studying AI and they're applying AI in their domain so that they can make a better career or they can earn more. So you would have known all these things. I don't need to say this once again. And you know about all these things, but you want to learn AI in the starting, but you don't know. You don't have any knowledge on AI. So you're a biomedical engineer or you are a chemical engineer who wants to learn AI, but you don't have the idea, you don't know the programming sides. Worry not, this is where we are going to help you. And in this video, we are going to see about the basics of AI. So in this video, we're going to talk about what is AI, what are the different branches of AI, what are the different terminologies you to know AI, and we were taking a real example of how we can understand ChatGPT with based on these concepts. So without any further ado, let's just jump onto the video. So guys, here we have with us the masterclass for basics of artificial intelligence, like all the basic terminologies you need to know about AI and machine learning are going to be dealt in this particular video. So this single video is enough for you to understand the basics of ML. So this is the agenda we have: basic introduction. We're going to look at the different branches of AI, then the different terminologies associated with AI, and then the different types of learning, and finally we'll see what different job roles are being offered in the AI industry. So we start with the introduction. So AI, I don't need to give an introduction about this topic. Everyone knows what AI is because AI is ruling the world. It's dominating the world right now. It's one of the leading technologies. And whatever applications you take in the world, some part of the process is being run by AI. AI serves as a tool of automation. So AI, as the name suggests itself, is artificial intelligence. So it's an intelligence that is exhibited by the machines. So we impart the intelligence to the machine and we make it work and make it do tasks like a human being. But there is a slight difference between the learning of human and artificial intelligence. We human learn through experiences and observations, whereas AI and the machines learn through data. So it collects experiences from data, whereas we collect experiences from real life scenarios by interacting and all the other things. So that's the difference, but still the AI has been inspired from the human intelligence. And we said how the brain works, a similar way has been encoded also. And we imply that kind of teaching to machines so that machines can perform specific tasks up to the level of human or even more than that also. So this is all about the base introduction of AI. I think I don't need to spend much time here to talk about the definition of AI because majority of you guys would be knowing what it is. And that's the reason why you want to learn AI in the first place. So next we go to different branches of AI. There are multiple branches, but these are some of the starting branches that I want you guys to know with because this is how you will be starting your study also. So some of the branches would be involved in the bundle to learn AI and machine learning, and some would be some extra necessary stuffs which we can call a specialization so that you can look upon later. But some things you have to learn in the initial level, and some things you can go for a specialization later if you're interested in that particular thing. So let's deal with everything. So we have machine learning, deep learning, robotics, expert systems, fuzzy logic, reinforcement learning, computer vision, and natural language processing. We'll go one at a time and we'll see what those branches do and what do they mean. So we start with machine learning. Same. So it's one of the fundamental branch of AI, which refers to the set of tools and techniques or strategies that we use to make a machine learn to do a particular task. So this consists of a lot of maths. So yeah, don't get feared. The maths is simple only. So the maths that is need to be learning, machine learning and deep learning, the maths that is required to learn those things are at your school level only. That is max to 12th grade. Whatever maths you have studied there, the statistics, the probability, and the calculus that you have studied there, right? That is more than enough to understand these concepts because the algorithms would be designed or would be inspired from those techniques only. So it involves the machine learning part involves more of statistics and probability based algorithms, and these algorithms will try to model the relationship between an input and output. So for example, let's say we have a data where we would like to diagnose cancer from patients based on blood test. So the blood test will have different parameters, like it will have some the cholesterol level, and then it will have the ammonia level, and then there are a lot of biochemicals and a lot of biochemistry involved in that. So we will be getting the values for that, and based on these values can we predict if the patient has some specific type of cancer or not. So we are giving these input and we are trying to determine output from that. So what we are trying to do is we will train a machine learning algorithm which will try to capture the relationship between the input and the output. If we know the relationship, so let's say input times 2 is the output, so the times 2 is the model which is trying to give a relationship between the input and output. So if you know that model, then you can just apply the relationship on the input so that you get the output. So this is a base level understanding of how a machine learning algorithm works. So this relationship, finding that relationship with the help of the input and output is what the algorithms will do during the training phase. And this is all about machine learning. So it uses a lot of math algorithms, and these algorithms are fixed. So you need not much work on designing the algorithms. You can just call the algorithms that are present already in code part, and you can just train on your data. So training on your data means it will try to find the relationship between the input and output, and it will understand it. And during testing, what will happen? You just give the input, it will apply the input to the relationship, and it will determine the output. So this is how ML works, and this is one of the core fundamentals of AI. So this is, I would say, this is the first building block of AI. So if you understand this, then you can stack up on your blocks and you can increase your understanding and skill sets in AI. So the next one coming to this is deep learning. So deep learning is a branch or it's a subset of AI, machine learning. So machine learning is on a broader scope, and deep learning is on a specific case of a machine learning. Why it's a specific case? Because it follows the same ideology of machine learning where you train mathematical algorithms to do a specific task. Here the algorithms are neural networks. And deep learning is like inspired from the human brain, because our brain has a biological neural network. So the brain consists of number of neurons, right? And one neuron communicates with each other and they get activated by electrical signals and all. So that's how like if I want to move my hand from here to here, then my brain gives the signals to all the nerves, but these nerves are not involved to lift this hand, right? So this hand is not going to be useful to lift this hand. So these neurons won't get activated, but these neurons will get activated so that I move my hand from here to here. So this is how a biological neural network works. So mimicking this using maths is an artificial neural network, and using that neural network to train the neural network on the given data is about deep learning. So we have lot of different types of neural networks, different working on different type of data. As the name suggests, it's a deep field only. So the architectures will be very deep. So unlike machine learning, where we can't call the algorithms, we have to design our own algorithms. In machine learning, you can call the existing one, but in deep learning, you will be designing your own algorithm, either from scratch or from existing also. Let's not talk in depth about each of the techniques, which because I am covering masterclass for each of these topics later. So this is about deep learning, which is a specific subset of machine learning. Next, we have robotics. So robotics is the software and hardware integration. So this is the part where both software and hardware comes into play. So where using the software, you design the algorithm and you implement that in a hardware device. So let's say we take an healthcare example where we have different sensors that is collecting the data. For example, we take the heart rate, we take the blood pressure, we take the oxygen level, and then we take some chemical levels from the patient using different sensors. So what we do is we take the data out of it and we train a machine learning algorithm which will map the input output relationship, and it will say whether the patient has any disease, cardiac disease or not. And then what will happen? You can just, once you train the algorithm in your computer or laptop, you can provide that algorithm for testing in an IoT chip there. So in IoT hardware device or chip or whatever it is, and it will do the predictions there itself. Instead of sending the data to computer and computer to back, you can do it in the same place. So this is called deployment on the edge deployment or local deployment. And you can give, so for example, if cardiac disease is there, then you can just give an alert. So this is how the smartwatches are working. So you would have known about Apple smartwatch or Google Fitband and all the other things. So they have sensors attached in the watch, and the sensors will be collecting the data. And machine learning algorithms are present inside the software chip itself, inside the hardware itself. The algorithm is present, which will try to do the machine learning analysis. And if there is any risk, then a notification or alert will be sent to the user. So this is a key example of how AI is involved software hardware integration with robotics. And this is a very small scale application. A large scale application is the industrial robots. So it will detect. So for example, if I'm taking an industrial robot in a factory setting, So I want to seal a packet of chips. Then I have to identify the chips, I have to hold and seal it, right? The holding and sealing would be done by the mechanical component, but AI is there to detect whether it's a packet of chips and where is the chip, so that it has to find the packet of chips so that it goes and acquires it, right? So this is where AI will come into place. So this is how AI as a software is integrated with the hardware to make intelligent robots. And this is all about robotics. Then we have expert systems. So this is a place where both AI and human come together. So this is a combination of both AI based rules and a user that is human based rules to do some decision making. So we saw AI based learning where the algorithms will try to map the relationship between the input and the output. So let's, for example, let's take a medical diagnosis itself. So we have the blood test of around 100 patients and we have the outputs of whether they have some disease or not. So based on these inputs and outputs, the AI algorithm will try to understand the relationship between input and output. So this is how the machine learns from the data. How a human will do the diagnosis, how a doctor will do. He will check at the different levels and he has his own rule system in his mind. So he has his own knowledge base. So he will create his own ruling system and based on that ruling system, he will do the diagnosis. So what if I give that ruling system to the algorithm? So it will learn from the data also, it will learn from the rules also, and it will give an enhanced decision making so that the accuracy or so that the reliability of the algorithm is better. So that's what we say human intelligence and machine intelligence together is expert system. So this has a lot of use in the medical field because medical field requires high accurate diagnosis, right? So machines can't make mistakes and mistakes are not tolerable in a medical field. So in that case, when we combine human and AI knowledge together, then we can develop an enhanced decision making system. So biomedical engineers, you can keep a note of this. There's a lot of scope here because this requires domain knowledge. A normal computer science engineer cannot develop an expert system easily, whereas a biomedical engineer can do because he needs to just understand the programming and the AI part. He already has an idea on the knowledge base. So he can easily integrate with a doctor and he can communicate with him. Whereas a computer science engineer needs to understand the domain of the medical and all the other things in order to develop an expert system. So here you biomedical engineers, you guys have a lot of chance, a lot of scope to develop expert systems because you have a knowledge of both. You have knowledge of technology, software, coding, programming, and you have the knowledge of the biochemistry, pathology. So all these subjects are there in your curriculum, right? So you can integrate and work with them seamlessly and you can develop expert systems better than that of computer science engineers, hassle free maybe. Next, we have fuzzy logic. So you guys would have already known about Boolean. So computer science students know what Boolean is. So it's a binary. So they say yes or no. Is it there or not? Zero or one is called a Boolean logic. Whereas a fuzzy logic is a continuous range from zero to one. So we have might be, probably, severely, most likely. So these variables can also be encoded and we can give a range of 0 to 1. So instead of giving a binary, we are giving a multiple logic. So that's called a fuzzy logic and we can develop systems out of this also. Next, we have reinforcement learning, which is more related to the human type of learning. So, how a human learns, he learns by doing something, and based on that, he will get some reward, and based on that, he will enhance or he will correct his decision. So, as children, we would have done this. Like, for example, we see a fire and a stove, and we keep our hand there because we don't know what it is. But once we get burnt, then we understand that we should not keep it 1 second because we are getting a negative reward, which is a punishment, the burn. And that reward or the negative punishment, negative reward or the punishment will tell the brain that you should not do this again. So this type of a learning that we mimic in the missions is called as a reinforcement learning. So we have some parameters like agent, environment, state, and reward. So agent is the one that performs the action on the environment after observation, and we as the interpreter will see whether the action is good or not. So if it is good, we give a positive reward. If it is bad, we give a negative reward. So it's like that. So based on this, the machine will also understand whether the decision it is making is good or bad, and this can help to develop enhanced decision making systems. So this is about reinforcement learning. Next, we have computer vision. So as the name suggests itself, it's the AI of the vision. So it's like the human eye that we are trying to mimicking and we are trying to automate using AI. So this is computer vision. So image will be looked as numbers by computer. So we look image with the help of the properties, with the help of the objects and all. But image computer cannot interpret an image. It interprets with the help of numbers. So based on these numbers, we give the numbers to the machine learning algorithms, deep learning algorithms, and these will try to do some automated tasks. So like we detect objects, right? So given a pile of objects, we try to find one object and we grab it. So object detection, segmentation, classification, image quantification, captioning. So for captioning nothing but from the image you generate a text. So all these different kind of tasks come in computer vision. It's a specialized field. So it integrates machine learning and deep learning, especially for image-based tasks. And now recently Gen AI has also been coming, right? So in computer vision, you can generate images, generate new from text, generate an image. So that's what this Llama 2 and all the DALI. You would have heard about DALI model of ChatGPT, OpenAI, right? So ChatGPT is one of the models OpenAI has developed. Is OpenAI has also developed DALI, so where you can give your prompts as text and it will generate image accordingly. So these are some generative AI algorithms that use computer vision. And the last branch we are going to talk about is natural language processing, which is the AI of linguistics or AI of text. So this is also a specialized field. There are a lot of it's a lot of challenging and a complicated field because there are grammatical rules and the way we pronounce words or the context in which we use the words are very different. And sometimes a noun and a verb can be used in the same place. And there are a lot of complex grammars, and it varies from language to language. English might sound simple, but when you go to French, it is complex. When you go to Tamil, when you go to English, when you go to Hindi, so for each language, the rules are different and language translation becomes difficult. So it's a very complex and complicated field. The brain is so powerful, and that's why we are able to easily understand the languages and versatilely switch between them. But the machine is not that much powerful, and it is trying to evolve. It is trying to improve and come to the level of human. And that's where you would have learned about, got to know about GPTs and LLMs, large language models, general pre-trained transformers. A very good example is ChatGPT. ChatGPT is an NLP application where you try to give text input, it gives a text as output. So you give some question to ChatGPT, it will search from the website or it will search from its own knowledge base and it will give you back the answer. So this is about NLP, all the other techniques that come inside NLP trying to automate text-based tasks. So these are all the different branches of AI. Next, we will see about some basic terminologies of AI. So if you know these terminologies, then you will understand about the different applications in AI. So how this application works, and the way you view the applications of AI will be different. So you will unlock a level of understanding once you know about these different terminologies. So these are the different terminologies. First is obviously data. So I would have mentioned about this, right? AI learns through data only. You have to give past experiences as in the form of data, and the algorithms will try to model the relationship. So there are different modalities also, like image, text, audio, video, and then a tabular data. So sensors and all can be acquired in a tabular format. So we call Excel sheet, SQL. So there are some specific databases which we can use to store the data in a tabular format. So there are two types of data, namely structured and unstructured. So this tabular data is structured because it has rows and columns format. But the images, audio, video, graph, all the other things, text and all these are unstructured because they don't have a proper structure, they're not fixed. So that's about unstructured data. So these are things you need to know about the data. And next is task. So what task is the algorithm doing? So what is the AI application meant to do? So what does ChatGPT do? It does question answering. It sometimes does machine translation also. For example, it translates from English to Hindi or English to Tamil, so all the other things. So what does the Tesla do? It does image segmentation. It does object detection. So you need to understand what are the different tasks the particular algorithm is doing or it is assigned to. And then what is a model? What is an algorithm? So what algorithm it is using? What is it trying to do? How is it trying to capture the relationship between the input and the output? And that is what will happen during the training phase. So that is what I've been saying around 3 to 4 times, right? So training is the phase at which the algorithm or the model will try to understand the relationship between the input and output. And how does it do? With the help of the past data. So when you give 100 inputs and 100 outputs, it will try to understand the relationship between the 100 inputs and outputs, and it will develop a generalized relationship. So the each algorithm will have parameters, and it will try to find the value of the parameters. So for example, x plus y is equal to 3 and 2x plus 2y is equal to 6. So these are two equations, and you try to find the value of x and y, right? This is what happens in the training of an algorithm. So x and y are the parameters of the algorithm, and 2, 2, 6 are the inputs and outputs. So you will fit the inputs and outputs, and you will try to find the value of the x and y, which are the parameters. And this is what happens during the training phase. And then deployment. So basically, you need to deploy the algorithm somewhere. So ChatGPT has both mobile application and website. Tesla is like a hardware application because there you don't like have a website for Tesla on how it works and all. So instead, the algorithms are deployed. So this is where robotics come into play. AIoT, they say, artificial Internet of Things. So AI plus IoT integrated together. So all these things come there. So about deployment and all the other things. And finally, learning. So we are going to talk about learning. Excuse me. So we are going to talk about learning in detail in the upcoming slide. So learning is the process or pattern by which the mission tries to understand the relationship between the input and the output. So it depends on the type of the data. It depends upon the type of the training and all the other things. So you need to understand how the different algorithms train also. What setting, what mode it is being trained on. So once you're able to understand all these things, then you would have unlocked the basic understanding. So now let's use this knowledge and understand what ChatGPT is. So data, what's the data? It is unstructured and text. Task, it does a lot of tasks. So, but the primary task is question answering. And model or algorithm, it's called the LLM, large language model. Training, how do they do? So what would they do? They take the data. So ChatGPT, the free version is trained till 2021. So the day from which internet started till 2021, whatever materials were available, they took all of the materials and they gave it to ChatGPT to train. So we need some outputs also. So the team of OpenAI team, they manually marked the outputs, and so they generated the questions and answers, and based on that, they trained the algorithm. Deployment, it's a website and mobile application. Learning, which is what we are going to see later, but it uses some kinds of learnings. Maybe once we talk about the different types of learning, I will mention what learning ChatGPT has. But I hope you would have understood about ChatGPT well, what's the input you give, what output it gets, how it is trained, what algorithm it uses, how it is deployed, and all the other things. So now we will go with the different types of learning. So there are around 16 different types of learning, which I have mentioned here. So we have supervised, unsupervised, reinforcement, semi-supervised, self-supervised, multi-instance, inductive, deductive, transductive, ensemble, transfer, online, active, and multitasks. There are many more also. We have multimodal, and then we have reinforcement is mentioned. So we have I'm not able to recollect. So there we have many more types. So the research, it's a very AI is an ongoing field and it is advancing, right? So we have research that's going on. So we have a lot of things that's going working on. So these are just the basic types. There are even more types that's evolved and being added to this list. So let's go with one at a time. So the first one is learning problems. So based on learning problems, we have supervised, unsupervised, and reinforcement. So supervised, as the name suggests, we have a teacher or we have a guide or a supervision. In this is the real meaning. In terms of AI or machine learning, we would say that the labels or the outputs are given. So we have the input, we have the output, we generate an algorithm to find the relationship between the input and the output. So this is about supervised learning. And the example is classification. Classification is finding whether a disease is there or not. So this is about supervised. Next, we have unsupervised learning. Unsupervised learning, on the other hand, is the opposite of supervised, and it does not have the outputs or the labels. So in this case, we give the inputs only, we don't have the outputs. So what are the possible tasks? An example is clustering. So clustering, as the name suggests, it will try to group the data into some groups based on similarities, or it will try to eliminate or keep aside the data which are not similar. That's called anomaly detection. So we will be talking about these methods in detail in the upcoming master classes. But just understand that these are the different types of learning. So if the labels are there, it's a supervised. If the outputs are there, supervised. If the outputs are not there, it's unsupervised. And reinforcement, we already talked about in that before. So reward or punishment based learning. Chess. So you would have known about alpha, deep alpha or AlphaGo. I'm not able to recollect the name. So this happened in 2001, I guess. So uh, we had a chess match between the chess grandmaster, world champion, and Kasparov. Gary Kasparov was the world champion at that time. He played against this particular chess algorithm with reinforcement learning. I'm talking 20 years back. At that time itself, RL was there. So it was basically a probability based algorithm. So for example, there are different combinations of chess moves, right? So when you play one move, the opponent or the opposite side, that is the algorithm, will see the different possibilities, and it will be learned from the different games. So from start of chess till now, how many games were recorded? So it will say, for example, when we push the pawn two steps, it will check. So if I play a knight move, or if I push this pawn or push that pawn, what is the probability that I will win? So it will check from the different databases that has played this move and it has won, divided by that has played the moves and total games. So that we'll get the probability for each move, and it will play that move which has the highest probability. So this is a very basic level of a chess engine game you can develop, and with this you can integrate RL also. So if it makes a move and it feels that it has made a mistake, so let's say it makes a move and the next move they do something and it gives a problem. So the engine will update accordingly by giving a punishment, and it will make sure that it does not make the move once again. So this is how it enhances the algorithm, and this is about RL. Next, we have this one, hybrid learning based algorithms, semi-supervised, self-supervised, and multi-instance. So semi-supervised is a combination of both supervised and unsupervised, where for some data we have the outputs and some we don't have the outputs. So out of 1,000 patients, we have 600 patients that have the data outputs and 400 don't have the outputs. So in that case, how do we train the algorithm? So these techniques fall under semi-supervised. And next is self-supervised. So this is hybrid learning, right? So we combine things. So in self-supervised, what happens is we take an unsupervised problem and we treat it as a supervised problem so that we can apply supervised algorithms. So what happens is we don't have the outputs, but we treat that it has outputs so that we apply supervised algorithms to it. So I will not go deep into this, but I'll just explain what autoencoder means. So autoencoder used for image compression and decompression. So the data itself will act as the output there. So input is output. So autoencoder is used for image reconstruction. The image is the input, and we develop an algorithm which tries to generate the image once again. So we don't need separate labels. We don't have the labels for the image, but we are treating it as a supervised problem by giving the same image as the output. So input the same coming as output is an autoencoder, and this is how self-supervised algorithms work. And next we have multi-instance. In multi-instance, some labels are present for the group and not for an individual data. A group of data, you would have the labels. For example, clustering itself. So how clustering works is, so the same 1,000 patient data we have, we do a cluster, and we, let's say we form 5 clusters out of the 1,000 data. And we just get the label of the entire cluster. All the group points inside the data get labeled because they are all assumed to be similar. This is about clustering. So how we have the labels for a cluster or a group, and we try to assign the labels for all the individual points inside it. So this is called multi-instance learning. And then next we have statistical inferencing based learning, inductive, deductive, and transductive. So inductive, as the name suggests, specific to general. So we train an algorithm for a specific case and we extend the algorithm for a general case. So it's a bottom-up approach. So from specific, we go to general. And deductive, on the other hand, deductive is an opposite case where we go from specific, general to specific. So we train our algorithm on something very specific and we use and deduct that knowledge. That's called deduct, right? We deduct from something. So we deduct that knowledge to a specific case. So that's called top-down approach. And transductive is specific to specific. So from one domain, one knowledge, we transfer the knowledge to another domain. So this is called transfer learning. So these are the things that happen in the statistical inferencing. From specific to general is inductive, from general to specific is deductive, and from specific to specific is transductive. So next we have the newest forms of learning, multitask, as the name suggests. So we saw ChatGPT itself, it can do more than one task, right? It can develop, automatically generate code also, it can generate images also, it can answer your questions, it can translate your questions to different language. So it does more than one thing at a time. So that's called multitask. And online learning is nothing but once you developed an algorithm and you publish it in a website, people start using it, meaning people give data to it. So there is new data. Why should I waste it? So I will improvise my algorithm in the training phase will happen during the deployment itself. And this is called online learning. So once your the algorithm is learned, you deploy it in a website, people start using your algorithm, they give you data, and after some time, you will get a lot amount of data and you update the model or you fine tune and enhance it by the real time data. This is called online learning. And then we have transfer learning, which we already saw. It was transductive learning. So an algorithm or a model is trained on one task, and we transfer that knowledge and give that learnings to an algorithm which is going to be trained on another task. And last is ensemble learning. Ensemble is a French word for together. So you combine algorithms together to develop an enhanced decision making system. So now we saw the different types of learning. So can we understand this with respect to ChatGPT? So from this slide, what and all learnings ChatGPT can have? It can have all actually. So the if the labels are provided, so if the team does the annotation, they label the data, then it is supervised. If not, it is unsupervised. But majority it is done using supervised only. They initially gave the outputs. And then reinforcement is present now because the reinforcement learning will try to improvise the algorithm and make it better. In this case, what we'll be having, is there anything else we can see? I think self-supervised can be happened, but I'm not sure. And from this case, do we have something? Yes, we have general to specific deductive. So we have some advanced techniques where we can use ChatGPT, a very general thing, to answer a specific question. So we have some techniques that will be integrated. So it can use deductive learning. And then here it does multitask. It has online also. So online and multitask learning are being used because it's very obvious, right? Once you use ChatGPT and you deploy it, a lot of people will be using it. And there are some cases the algorithm will do it wrong. It will give a long output. So the scientists or the engineers on the back end will understand this and they will collect the data. They will change it and they will make the algorithm better by making it to learn on that data. So this is called online learning. Finally, we'll come up with the different roles that are present in the AI industry. So one, like, this will give you a motivation to start your learning because I'll be mentioning the different roles, what they do, what skill sets they need, and what's the average salary in US environments and in Indian environments. So it's an average. However, it completely depends on your performance. So these are the different job roles. We have data analyst, data scientist, data engineer, machine learning engineer, MLOps engineer, prompt engineer, Gen AI engineer, and robotics engineer. So some of these are standard and some of these are newly developed roles. So prompt engineer, Gen AI engineer, MLOps and all are something very new. Whereas the other things have been excuse me, have been present for a lot of years. So this is just a small summary description of all the thing. So data analyst will be more focusing on analyzing the data sets and extracting insights from it. So he'll be working mostly on structured data, tabular data, and he will be using tools like Excel, Power BI, Tableau, SQL, Python, and all the other things to extract insights. So he'll be doing data visualization. He'll be applying statistics to extract insights from the data. So let's say we have a survey data of a particular area. So they will try to find out the families who have children more than three, or they will try to find the number of available plots, how much percentage of free plots are there. So these kind of different statistics or visualization they will do to extract insights. And we have data scientists which does more than an analyst. They will be working on the machine learning side also. So they will be do working on the problem solving. So they will solve complex problems, they will develop algorithms to do automated tasks, and they will be doing data analyst also. So we have Python or R you can use, and then we have TensorFlow, PyTorch for deep learning applications. We have sklearn for machine learning applications, and all the tool sets that data analysts use in data scientists will also be using. Data engineer, on the other hand, will be focusing more on the data pipelines, how the data can be fetched, how the data. So, for example, when you take the sensor data, how can we get data from the sensor and how can we develop a structured data out of it and how do we automate it so that this is being done in an automated cycle. So, we have cloud-based tools, we have big data tools because sensors, if it is collecting data for a long, so let's say it is collecting one data per second. So in a day, you would be having 86,400 data points, and in a month, you would be having a large amount of data, right? So you need some big data frameworks which will seamlessly integrate and collect the data. So that's where we have Hadoop, we have Spark, we have Apache. So all these things are some of the tools that are used for big data. And ETL refers to extraction, transportation, and loading of the data. Sorry, extraction, transformation, loading of the data, ETL. So that is also being used. And then we have cloud algorithms, which we cloud, I can't say algorithms, some architectures or some frameworks of cloud. AWS is of Amazon, Azure is of Microsoft, and GCP is of Google. So you need to know these frameworks so that you can integrate in cloud and it will be storing the data in a cloud instead of physical hard drives. You're using virtual hard drives to store the data and to automate the process. And then we have machine learning engineer who is very specific to machine learning. He would not focus much on data analysis, visualization, and all. He will be focusing more on developing ML and DL pipelines. Who will be going in depth in the analysis algorithm side. So developing CV, NLP, RL, GN, and all these advanced things he needs to know. An MLOps engineer is more on the deployment side. So how can we develop an algorithm? How can we deploy it? And how can we constantly update it? So the online learning and all the other things This will be coming in an ML ops side. So machine learning operations. How can we update the model? How can we save the model? How can we use it in a website? All these things you will be looking. Automation, monitoring, all the other things. Prompt engineer is mostly developing prompts and designing the input and output for LLMs. So how can the GPTs and all the generative AI algorithms learn better? How can we design prompts? How can we design the input and output cases so that they learn better? This is about prompt engineer. And then Gen AI is specific a role case for Gen AI algorithms to develop generative AI, like AI algorithms for text, images, or generating any other data, improvising the data, all the other things will be working. It's a very hardcore and a very advanced field. You need to have a lot of knowledge and you need to know about a lot of algorithms, programming, and all the other things. That's what I've mentioned. LLMs, Hugging Face is for text-based algorithms, generative AI algorithms, then TensorFlow, Python, PyTorch, Stable Diffusion. So these are some of the things they need to know. So it's a very advanced field. You need to have a lot of skill set to work on that. And we have robotics engineer that we already mentioned, AI software and hardware integration, where you work on the both sides, you develop algorithms and you integrate them to the edge deployment, local deployment, and all the other things. So this salary is just average I took from the internet based on sources, references. So where the salary is annual salary in India and in US environments. This, however, is not the real test case. It will be based on your skills and your performance in an interview. But these are the different jobs or the different genres of AI that is being available in the industry. So with this, we come to an end to this workshop, also then to this masterclass. So do like this video, do share this with your friends who are interested to learn AI, know about the different things of AI, who has an interest in AI but doesn't know how to start, where to start. So this would be a great point to start for everyone. And don't forget to subscribe to Biomed Bros for such interesting and fun content. A lot more of masterclasses are going to come. So individual topics like machine learning, deep learning, data analytics, all these things we are going to cover up specifically in both theory and practical modes, how we are going to do, and all the other things. A lot of master classes are going to come. So stay tuned and subscribe to Biomed Bros to know a lot more about this. So finally, signing off, Saram Aditya. Bye bye, guys.